All right, we got our day 4 notes, so we're going to go through this on this video. I'll be back soon, so here we go. We'll do 3 at a time. I'll give you like a minute for each set of 3 here. So here's your first 3 vocab words. So parallel lines are 2 coplanar lines that do not intersect. Let's zoom in there. Cool. All right, and then intersecting lines are 2 lines who cross each other in a plane. And then perpendicular lines are 2 coplanar lines that intersect at right angles. So I'll give you 1 minute starting now to get that down. All right, so here's the next 3. Oblique lines are 2 coplanar lines that intersect but are not perpendicular. So basically, intersecting lines are called oblique lines. Skew lines, we talked about this on day 1, 2 non-coplanar lines that do not intersect. So they don't cross, but they're not parallel. They're on different planes. And then coincident or coinciding lines are literally the same line. They lie on top of each other. I'll give you a minute right now. Oh my gosh, I'm sorry. It's just not zooming in. There we go. All right. Moving on to the next ones. Let me zoom out. This is bugging out, and this is kind of frustrating. Sorry about that. Okay, and then moving this down. All right. So I guess the last one there is transversal. So I'll give you a few seconds. Go ahead and write down transversal. It is a line that passes through 2 lines in the same plane at 2 distinct points. All right, so let's go ahead and get these corresponding angle postulate. All right, it says if 2 parallel lines are cut by a transversal, then the corresponding angles are congruent. So I'm going to mark some with arc. So this right here, if I can get this to work. So this angle and this angle, okay, corresponding angles. So here's the deal. Corresponding angles are in the same position. What do I mean? So for example, see how these two are in the bottom right? Bottom right. Okay. It's almost like it's just been like shifted down the transversal. Okay. Another way to think about it, it's on the same side of the transversal, but one is interior and one is exterior. And again, it's very important that that means they're in the same position. Okay. Cool. So that's kind of what a corresponding angle looks like. So if two parallel lines are cut by a transversal, corresponding angles are congruent. So very important that these are congruent. Think of the C rule. Corresponding C are congruent. Cool. Let's talk about the next one. Alternate interior angles postulate. If two parallel lines are cut by a transversal, then alternate interior angles are congruent. So here's what they look like, okay? Alternate interior, okay? Here's an example right here. This angle and this angle, okay? So alternates are congruent, that's important, okay? So they're alternate sides of the transversal, okay? If I can write transversal, but they're interior the parallel lines. Okay, so do you see how these two arcs over here are on different sides of this transversal? I'll call it T for transversal. Okay, they're on different sides of that transversal, but they're in between the two parallels. Okay, so if they're parallel lines, then alternate interiors are congruent. That's very, very important. Okay. All right, let's go to the next one. Very similarly, okay, alternate exterior angles. If two parallel lines are cut by a transversal, then the alternate exterior angles are congruent. So what do they look like? Alternate exterior, here's an example. This and this, those red arcs, okay? So important, alternates are congruent, okay? So kind of like the one we just did, if I can scroll, they're alternate sides of the transversal, okay? But they're exterior the parallel lines. So again, if you look at that picture, so they're on different sides, alternate sides of this line T, the transversal going through them, but they're outside the two parallel lines. Okay, so alternate exterior. All right, I'm going to move it down. Let's do the next one. Sorry. All right, if two parallel lines are cut by a transversal, then the same side interior angles are supplementary. Okay, so here's the same side. This is the S rule. Same sides are supplementary. So if we're talking about same side interior, here's what they look like. Okay. I wish that would go away. Let's try to get rid of that. Okay, so now here we go. So these are on the same side of the transversal. So again, here's my T transversal. These two angles are on the right side. They're on the same side of the transversal, and they're interior the parallel lines. Cool. So you can see, just by the way it looks, that those two angles are on the same side of the transversal to the right, and they're in between the parallels, so they're interior. Same side interior, and the S rule says same sides are supplementary. Okay, well, let's take it to the next one. If I can scroll down, there we go. And then the next one, same side exterior. If two parallel lines are cut by a transversal, then the same side exterior angles are supplementary. All right, so same side exterior look like this. Okay, as you can imagine so far, same side means same side of the transversal, and then exterior, the parallel lines. Okay, so again, here's my T transversal. They're on the same side to the right of the transversal, but they're outside or exterior the two parallel lines. Okay, those are all of my angle relationships. I'll give you a second to make sure you wrote that down. All right, let's do 1 through 8. Okay, so we're gonna name these relationships or put none. Okay, so number 1 through 8. Just a little zoomed out. There we go. All right, 1 and 5. Okay, so if you look at 1 and 5, so 1 is acute over here, 5 is obtuse over here. Okay, now here's this line going through the middle is my T transversal, right? So the parallels are going up and down, or they're more vertical looking, but the transversal is definitely horizontal, cutting through them. So those two angles, are they alternate or same side? They're same side. And are they in between the parallels? or outside the parallels? Outside. So they're same side exterior angles. Okay. Number 2, let's talk about angle 2 and angle 4. So angle 2 is obtuse, angle 4 is obtuse. Now, do those look same side or alternate from the transversal? And I would say those are alternate sides of the transversal. And are they in between the parallels or outside of the parallels? In between the parallels. So that's alternate interior angles. Okay, number 3, what's the relationship between 3 and 6? This is the trickiest one. 3 is here, it's acute. 6 is here, it's acute. Now, if you look at 3 and 6, they are on the same side of the transversal. But notice 3 and 6, one is in between the parallels, one is outside the parallels. They're not both interior, they're not both exterior. This is the unique situation where you have the same angle shifted over down the transversal and they're congruent. This is what we call corresponding. Okay. All right, 1 and 3. Now, this goes back to like day 1. 1 and 3 are at an intersection across from each other, and they're both acute, they're both congruent. So angles that are just across from each other at an intersection are called vertical angles. Okay, all these are angles, so vertical angles. Now, what about 4 and 6? These are one obtuse, one acute. They don't match, but together they make a straight line. What do you call a pair of angles that make a straight line? Again, this is a throwback to day 1. Linear pair. So again, when they're like at the same intersection point, they're either going to be vertical angles or a linear pair. Okay. 1 and 6. Now, this is acute. This is acute. They're on different sides of the transversal, outside of the 2 parallels. What do you think this is? Alternate exterior, outside the parallels, different sides of the transversal. Okay. Okay, 3 and 4. 3 is acute, 4 is obtuse. They're on the same side of the transversal, below it, and they're in between the parallels. So what could that be? Same side interior angles. All right, and the trickiest one, angle 2 and angle 6. Okay, 2 and 6 don't match. One's acute, one's obtuse. They're not on the same side of the transversal. They're not both in and both out. This is one that has no relationship. We've talked about this can be or none. Okay, we don't know. All right, scrolling to the next thing. Does everyone have 1 through 8? Now the next thing is going to be, if I can get this to zoom out. Okay, it's too much. I'm very sorry. 1 second. Okay. Now we want to find these missing angles. Okay. Now here's the trick when you're doing this. Please. My laptop is not cooperating. My apologies. Okay, so here's the trick. Okay, if this is 70 and that's acute, then these alternating angles. Do you see angle 1, 3, and 6? Do you see how they're kind of going in like a zigzagging pattern? All those acute angles are going to be congruent, okay? So that's 70. Angle 1 is also going to be 70. It's a corresponding angle. Angle 3 is also going to be 70. That's an alternate interior angle. Angle 6 is going to be 70 because that's a vertical angle. And all those relationships are congruent, okay? So do you see how 70, 70, 70, 70, they're kind of going in a zigzagging alternate pattern there? So angle 1, go ahead and put 70. Angle 3, go ahead and put 70. Angle 6, go ahead and put 70. Now, the rest of these missing angles, angle 2, angle 4, and angle 5, are obtuse. They are the what we call supplement. Okay, if you subtract 70 from 180, that's what we're going to get for these missing supplementary angles. 180 minus 70 is 110. So that means angle 2 is 110 because that's same side interior of the 70 degrees. Angle 4 and angle 5 are both linear pairs with 70 degrees, so they're both 110, 110. And even this mysterious blank angle over here is 110 because they go in a zigzag pattern. Do you see how they're zigzagging up and down and up and down? So if you know one angle in a parallel transversal situation, you can use that one angle to find all the missing angles. So put 110, 110, and 110. Again, they go in a zigzag pattern. All the acutes are congruent, and all the obtuses are subtracting from 180, and all those are congruent too. Okay. Okay. So go ahead and let's go to proving lines are parallel. Okay. So let's go ahead and get all these down. Okay, I'm gonna leave these 5 up here. You can go ahead and write these down. These are the proving lines are parallel converse theorems. Okay, go ahead and write that down. All right. Well, hopefully you got those down. Let's try these examples here. Are these lines parallel? Okay. So those corresponding are congruent. So yes. By what? By what standard? Okay, that's the first one we did here. The corresponding angles converse. Okay, B. Are these two lines parallel? Well, I see those alternate exteriors are congruent. So yes, by alternate, we can abbreviate, alternate exterior angles converse. On letter C, these alternate interiors are congruent, so that makes those two lines parallel. Yeah. By alternate interior angles converse. And then letter D, it says angle 1 and 2 add up to 180. Well, we know that if same side interiors are supplementary, adding up to 180, then that makes the two lines parallel. So yes, by same side interior angles converse. Okay, so it works both ways. All right, cool. So let's go ahead and try some examples here with some algebra. So we're going to do each of these one by one. Okay. All right. So find the value of each. Now, first of all, what are these two angles? Okay. They're in the same position, shifted down the transversal on the same side, one in, one out. What kind of angles are these? They're corresponding. And if they're corresponding, are they congruent or supplementary? They're congruent. Okay, so if they're congruent, I'm going to set these values equal to each other and solve for x. So 79 equals x minus 10. To get x by itself, I need to get rid of that loner minus 10 by adding 10 to both sides. 79 plus 10 is what? 89. Okay. So x is 89. That's kind of cool. And then if I'm looking for angle 1, if I know 79 and angle 1 make a straight line of 180, I could subtract 79 from 180, and I'll get 101. Okay. So that's a corresponding example. If they're corresponding, they're congruent, set it equal, and solve. Over here, okay, I have 50 degrees here. I have 5x minus 40 here. What kind of angles are those across from each other at an intersection? Vertical angles. And what do I know about vertical angles? They are congruent. They match. So if it's congruent, then I can set them equal to each other. So 50 equals 5x minus 40. And it's a two-step problem. Solve for x. Let's get rid of that loner minus 40 by adding 40 to both sides. 50 plus 40 is 90. Sorry. And then to get rid of that 5 coefficient, we divide by 5. We get 18 for x. Now, angle 1 up here is corresponding to this angle here, which is congruent to this angle here. So again, you can do the zigzag method that up here this is 50, this is 50, this is 50, and then this is 50 degrees. Cool. So remember, zigzagging, all the acute angles have to be congruent. They're all 50 degrees. Cool. Yeah. Let's go ahead and move down here. I'm very sorry, I cannot zoom out. It's crazy. All right, so this is where it gets a little bit more difficult. Everyone paying attention here. So this angle is acute. This angle is obtuse. They don't match. They're on the same side of the transversal in between the two parallel lines. Do you remember what we call these types of angles? Same side interior angles. Okay, same side interior. So this means they are what? Are they congruent or supplementary? S rule says same sides are supplementary. They add up to 180 degrees. Okay, so here's what you got to do. You're going to take these two values and add them up equal to 180. So 5x minus 40 plus 12x plus 16 equals 180. Okay, 5x minus 40 plus 12x plus 16 equals 180. Okay, let's combine like terms. What's 5x plus 12x? 17x. What's negative 40 plus 16? Negative 24. Bring down equals 180. And you can get rid of the loner, minus 24, by adding 24. And then you got 17x equals 204. And then your last step is to get rid of the 17 in front of x. So you could, in your calculator, if it works, here we go. When you divide it, you get 12. Okay. And you can plug that 12 back into these equations. So let's figure out this bottom angle, 5x minus 40. 5 times 12 minus 40. So 5 times 12 is 60. 60 minus 40. The acute angles are going to be 20 degrees. So 20, 20, 20. So angle 1 is going to be 20 degrees. Now the rest of these angles are supplementary to 20. So 180 minus 20 is 160. So the rest of these angles would be 160, 160, 160, 160. So angle 2 is 160. Again, alternating angles are all the same, and then the other 4 subtract from 180. All right, on this one, these are same side exterior angles, very similar. This is obtuse, this is acute. They're going to add up to 180. Combine like terms. Now negative 23 plus 23 cancels out. Divide by 12 and we get 15. And then you plug it back in. 2 times 15 plus 23 is 30 plus 23. 53 degrees for these acute angles. And then 180 minus 53 is 127 for these obtuse angles. Okay. I know that's a lot. It's kind of complicated, but at least you have an example to refer back to. But you're going to work on this homework day 4 using what you know about these angle relationships. Okay. So go ahead and work on day 4 and make sure you complete it. There should be a key for the sub to help you out as you're working.